All right, everyone, so this is the last video. When you're done with this video, you're going to be moving on to another page doing your practice problems. And I'm on page 10. And the last thing that we're going to cover, which is pretty important of all the different things, is how do we go, so I'm actually back on page 8, from standard form to vertex form. So this is the last one that we're covering. So of this highlighting, the stuff in green is definitely more important than the orange, although they're still all important, okay? So to go from standard form to vertex form, in your freshman year, you talked about completing the square. So back on page 10, let's go over that. All right, so again, to go from standard form to vertex form, we need to complete the square. And this is one thing that I don't think any teacher can do differently. We all tend to do this the exact same way. So what we're going to do is when we complete the square is that we're going to get these from standard form. Standard form, again, has no parentheses. It's just terms, and the terms are separated by your addition and subtraction signs. And we're going to get them to vertex form. And vertex form has the parentheses with the squared behind it. So the first step that I do is I kind of separate my x terms from the non-x term, from this constant. And when I separate them, I'm going to put these x's in parentheses. And since this is called completing the square, I'm going to be putting a square right here, and we're going to be putting a number in there. And then this plus 7 is going to be outside of my parentheses, and I'm going to be adding a square. And I'll explain why I have a plus and a subtraction when we get into this. So again, this should be familiar to you because you did do this in Algebra 1. So the number that has to do all the work is this term, the number that is connected to your x. And I'm going to take that number and I'm going to always cut it in half. And once I get that value, I will always square it. And just remember that 4 squared is 4 times 4. And I would really suggest you write these steps down because when we write our final answer, there's some tricks to this. So we just made a perfect square. That's 16. And that 16 is going to go in this box. And the idea is I got to keep... I'm just finding an equivalent form to this problem. So if I all of a sudden just add 16 to this problem, this isn't the same problem anymore. It looks a little different. So to keep it equivalent, if I'm going to add 16, then over here I want to take away that 16 because technically those two would just cancel out, as we like to say, and I still have x squared plus 8x plus 7. So from there it's pretty simple. What I'll do is I always start outside of these parentheses and I just look at this and I do 7 take away 16, and that is going to give me -9 or subtracting 9. And now what I'm going to do is make the parentheses squared that falls in with the vertex form. And it's always x and then plus or minus some number. And what you'll do is if you see the squared here, you need a number in front of it. Well, you can actually just look at this squared and see that number in front of it. And that's the number that will go there. And I'm going to put plus 4 because it's a positive 4. And I have just changed this from standard form into vertex form. And again, if you want to check to see if your answer is right, just go to your y equals button on your calculator, type this one in, go to a different y equals and type this one in. And when you hit zoom 6 for graph, you should see only one shape because these are the same graph. They just look different, but they're equivalent to each other. So let's try this one. So x squared minus 6x plus 10. So again, I'm just going to group these x's together in parentheses. And I will be completing the square, so I'm going to put a square here, and that 10 will fall outside of it, and I'll put a square here. And again, this number does all the work, and I have to see this minus 6x as a -6. So I'm going to take -6, I'm going to divide it in 2, which is -3, and then I'm going to square it, so -3 times -3 is 9. And do not use your calculator to square -3. Just do that in your head, because if you don't type it in correctly, it will give you -9 instead of 9, and that's not something I'm going to go into in this video. So now that I've made a perfect square, that square is going to go in this box, and since I added 9, these aren't equivalent anymore, so what I want to do to keep them equivalent is subtract 9. So again, those would just cancel out and I still have the same problem. Again, I always do this the same way. I come outside of the parentheses, just 10 take away 9 is 1. It's a positive 1, so I'll put plus 1. Now I'll make my parentheses square, and it's always x plus or minus a number. And look for here and go to this squared, and you'll just put -3, or you could put plus -3. And again, if you want to check to see if this is right, put this into Y1, put this into Y2, hit zoom 6, and you should see the same picture. So I'm just going to show you one of these extra problems. In order to complete the square, our leading term has to be x squared. I can't have a coefficient. I shouldn't have a number in front of it. And so what I'll have to do is when I group these x's together to make it look like x squared plus a term, I will have to factor a 2 out of these two. So I'm going to factor that 2 out, like that. And then I'm still going to add my square, plus 3, and then I'm going to subtract my square, and I'm still going to do the same thing. I am going to take this -4, cut it in half, and then square that, and then this is the number that goes in here. So normally, you know, it's been 16 here, subtract 16, add 9, subtract 9. But when I wrote 4 down, it's actually not worth 4 because this 2 technically distributes to everything in here. There's the 2x squared, there's the -8x. So this 2 really does distribute the 4. So even though I wrote 4 down, when the 2 distributes in, it's actually worth 8. I don't know if you can see all those fingers. So even though I wrote 4 down, I've really added 8, which means over here I'll have to subtract 8. And that tends to be the biggest mistake. One, we forget to factor out the 2, and that we forget that the 2 is involved, and that turns it into 8. So anyway, picking up where we left off. So 3 take away 8, that's -5, or subtracting 5. Here's my parentheses squared. And then it's always, again, x plus or minus something, and the number in front of the squared is the number in front of here, so I'll put -2. And the last thing I want to realize is that this 2 that I factored out is still hanging out in front of those parentheses. We're going to leave this one alone. It's a good thing to talk about when we come back from fall break. And so now you're going to finish up your practice. The last part of your practice will be on page 13. And there are 4 problems for you to do. And actually, what you're only going to do are these 2 problems. Okay, so you're going to do A and you're going to do B. And this one's good to go. So when you're ready to start, you can just set it up. But when you do this one, you will, when you group your x's together, need to factor out that 3, which I'll help you get started with. So again, when I grouped my x's together, I factored or divided out this 3 and got that, and the 3 from here and got this. And so now this is the number that does all the work, but be careful. Where these numbers will match, these numbers will not match. And if you get stuck, just go back, take a look at your notes, and again, just notice that they didn't match before. And then that's it. When you're done with this, you're going to show them to the substitute. He'll check that off, and then you're done for the day. And that's it. I hope you have a great fall break, and we'll see you somewhere in October.